So this is the behind the sparks video of the countdown clock. This project was developed in the frustration my wife had for her Nightmare Before Christmas countdown clock. This clock was sold at Spirit Halloween. It's a Disney product. Nightmare Before Christmas. It had cubes that went into these spots, and you had to pull them out and change the date. The problem was out of the box, it didn't have the correct numbers, so she had to redo that to get the correct numbers, because say it was 111 days, maybe there wasn't an extra one, something like that. I don't remember the exact number, but it was super frustrating for her. Came with Halloween or Christmas. She is a Halloween nut, so she only wants it to display Halloween. And I said, you know what, I think I can electrify this thing a little bit and put a ESP32 on the back and figure out the date. So I started looking into it, and how can I do that? Well, they sell these shift registers. Excuse me, it's a LCD display, 7-segment display, and it has a built-in shift register on it, and just with 5 wires here, you can set a specific date. So I did that and got a prototype going, connected up with the ESP32 and had a working prototype. The problem was, how do I get these displays into this hole? And obviously I needed a way to connect everything. Now I could redo all the wood, somehow figure it in there, but honestly the display height was exactly what that cutout was. So all I needed to do was make some fillers to go on the side here, and these are 3D printed fillers that are glued to these displays. So once I got that working prototype, I took apart some of these displays and got the PCB, and then I purchased some new displays and figured I'd get some multicolored wiring here. Like, these are pre-soldered. They're used for breadboard interconnects, and it's perfect length. There are different colors. They've already got a 10 solder on one side, so I could create a harness basically for these LCDs display, and then use multiple colors, so I knew each color matched the segment. So if you look at these displays, you can see, let's go ahead and go down here, that each segment has a number code. So A, B, C, D, E, F, G, right? And then the output pin goes to each one of them. These are common anode, which means the positive goes through the common, which is pins 3 and 8. And then basically it's seeking a ground. And that's the way the current flows through these diodes. In my prototyping, like I said, I was able to figure out a way to safely remove these LCD displays and use the board. And then I, like I said, purchased new displays and wired them up like this. And then with the goal of reattaching the wires to the back of the clock, and I did, and it seemed to work. There's a problem with, when I was doing some troubleshooting, I kept getting artifacts, like I get a segment here on this display and a segment there that was off. They weren't doing the correct numbers, but in my prototype it worked flawless. So there's something going on between putting these on wires, and I also added a resistor because I didn't like the brightness of the display. Statically, these are driven with a 47 ohm resistor. These little, which I don't know if let's see if I can zoom in a little bit. There's a little gang resistor right here that's 47 ohms for each one of these segments. So I had found that pretty much doubling that was going to help reduce the brightness a little bit. So I had added a resistor to this leg right here. And if I have some photos, I'll put some photos up. So you'll see in this photo a picture of the prototype board attached to the back of the clock. When I was doing troubleshooting, like I said, I kept getting artifacts or the digits wouldn't be right. I removed them. I actually got another board, tried it, and kept having the same issue as random artifacts, random digits appearing. And after considerable troubleshooting, and researching them with AI and whatnot, I finally came to the conclusion there was something in the design of this board that when I added the extra resistance and the wires, something in the shift register was not working right. So I had to abandon that. Luckily, I was able to search around, and I ended up finding some just single shift registers. So that's what, like this one is. This is just a single shift register, and it has outputs for the 8 legs of the LCD. 1, 2, 3, 4, 5, 6, 7, 8. So it would include the decimal point. And you could take and cascade these, for, 3 of them in a row, and that would work. But I also, in searching, found one that already had 3 and included pretty much everything I needed. So this is going to basically do the same thing that this one did, but it doesn't have any resistors built into it. So it's just 3 shift registers and the associated outputs. And that worked flawless. So this is my prototype board that I used. So I've got the shift registered module plugged in with to the ESP32, going through resistors, which are kind of hard to see in there, resistors, and then to the displays. And so obviously that worked. And so we move on to the actual build. This is the final unit installed. And so basically what you're going to do is just take these displays, you're going to solder your wires on it and heat shrink it. They are going to get bent in like this, kind of interchanged. So one goes, one goes, one goes, because the pocket in the back of this is not quite big enough to accommodate when it's sticking out like this. And they'll do fine. I've taken these things in and out. I haven't had any problem with them. I ended up cutting the wire down just a slight bit. You can see on this one, just enough so I got some solder, and then I can put some heat shrink on it. You do not need to do the decimal point. This is what this is. It's not being used in this application, but this was one that I was playing with the prototyping, trying to figure out maybe the fact that I didn't use the decimal point was screwing up the shift register. I really don't know what the reason why I had to abandon this and went to the other one. But so you do that, get your wires in place, and obviously you want to have some different wires so that you know each segment. So what I did was printed this out and I assigned a wire color. So white, red, black, orange. I didn't use the decimal point. Green, yellow, blue, black, excuse me. Blue and brown. So that kept consistency. So when I pulled them through, I still knew what segment was what. I also tested. So as soon as I soldered everything up, I test to make sure each segment was working correctly. And then I heat shrink and then installed, and then soldered everything up. So in this instance, it's double-sided tape down with some VHM 3M, very high. And then this is very tedious to get all these soldered down. So there is a resistor. These were 1K. That's what I found was a tone down the brightness. These are super bright red LED these displays. I'm sure that you could get some that weren't super bright, but these were cheap on AliExpress. I think I got a bag of 10 of them for like a couple bucks. Really can't beat them. So cutting the hole in this, I went at an angle, and I wish I'd thrown that away. So I went at an angle through the hole so that I wouldn't hit the back face of the clock. It's really not a big deal if you did, but I was trying to avoid that. So like in the center one, I just went straight down towards the bottom, and then these I curved so it would be kind of like this way, this angle, just so I didn't pop the back side of the clock face with the hole. And like I said, if you did, it's not a big deal. Actually, when I did this, I actually took this face off and marked an outline of where it sat. You don't really need to do that. It was a complete waste of time for me doing that. So anyhow, wiring everything up, everything goes in order. So starting with 0, 1, well, each one has a number. So on this board, it has 1, 2, and 3. So 3 different displays for 3 different shift registers. And then you've got 0 through 7. 7 is the decimal point, so we didn't use that. So you got segment A, B, C, D, E, F, G, right? And then it repeats again. Then there's decimal points skipped, and then A, B, C, D, E, F, G. The grounds, which are not the grounds, but the commons, I should say, are go to 5 volts. So I cascaded them, so I used both on the display, which is 3 and 8. So here we have the black wires, this one and this one. You don't need both of them because they are interconnected in the display. I just used them for redundancy as well as to cascade them. So I started out here with VCC, and that went to that display. Then the other leg of the display connected with the number 2, and then another leg connected with the number 1, and then the number 1 went and connected to this. That's this black wire right here, connected to VCC, which also connected to this VCC. You'll see the wiring diagram on my GitHub. We'll have the wiring diagram, give you a little bit more visual on how the wiring was done. In the ESP32, now these can be cascaded. You can, add another board if you wanted more displays. You wanted to do a different application, you could certainly do that. You just put these pins next to the next one, and then you could cascade, I guess, as many as you want. I'm pretty sure there's probably some kind of limitation, but you could do as many as you want type thing. So powering the thing up, we're going to get the backlight come on. Give us a better look. So she's going to come up with date. So this is the app or web page that you're going to put on to configure it. You can change the date. So today is the 25th of May. I'm going to go to the 26th of the target date. I'm going to set it. I'm going to save the settings. Save. So it's rebooting. That should change to a 1. There we go. And then this is going to refresh and pop back, and it should say a target date of the 26th, which is tomorrow. You can change your time zone, and then it also has the target there. It tells the time zone. If you need to change the Wi-Fi, you change the Wi-Fi. I'm going to put some screenshots here. Now, when you first do this, Wi-Fi Manager allows you to, you would first go on this web address, I believe it's 4.1, and it's going to ask for your connect to the Wi-Fi. Sorry. So you would first go onto a device. It could be a computer, anything that's connected to your home network once it's powered up. And I'll show screenshots here. That is going to, you're going to go connect to the Wi-Fi that says countdown clock. And then it's going to have a password that you're going to have to put in for that Wi-Fi. And it's countdown 1, 2, 3, 4. 1, 2, 3 countdown. And then that is going to give you a page that you put in your Wi-Fi credentials, which you'll see a screenshot here. So you can just tap on, like if you're on your phone, tap on your Wi-Fi. It will populate the box, and then you input your home Wi-Fi password. At that point, the ESP32 will connect to your home network, and then you can go on to your device and go to a web page, and it's going to assign, your router is going to assign a unique address for that device. This happens to be 63. You can see this happens to be 63. Everyone will be different, so you're going to have to go on to your router and see what that is assigned. There is other apps that you can use that will show you the devices that are on your Wi-Fi network, but if you have multiple ones, it usually just gives the word generic. But if you go onto your router, it's actually going to show you, it's going to say like ESP32 with a number. And that would be easier to identify what your actual web address is for that device. Unfortunately, I haven't found, I'm sure that maybe there is a better way to find that address, but everything that I've come across says you kind of have to go onto your router to look and see what where that device is. So everybody has a unique router, different things. You're gonna have to figure that out on your own. But once you get that address, then you can go to that web page and it will pop up this where you can configure the clock. So let's go ahead and set it to back to Halloween. So October 31st, Eastern. I'm going to save the settings. It's rebooting. And then it should come up with the target date. Supposedly, it should work for leap years and kind of whatever things you do. Obviously, you're limited to 3 digits, so it's not going to do multiple years. Maybe it'll do 2 years, obviously, but it won't do 3 years out. What other things could I tell you about? So, other pitfalls that I had was, so I had done this ring because I thought it would be a neat effect, which it is. It has a glowing, this is purple, glowing purple lights from the background. I'll show an image of it on my wall so you can kind of see how it looks. These are LEDs. I put them in the description. There's also a file for this ring that's 3D printed. I put it in this orientation so you can kind of see. I'm going to go ahead and unplug it so it's not so bright. So the cord kind of has enough access to go through here, and then it sits on the top like this. I found if the cord is sitting on this side, it's obviously going to disperse the light differently and it won't glow as nice. So the LED amount was perfect. I just cut it out like this, allowed the cord to go over, and then the clock will actually sit very nice on the wall because these feet actually stick out, and it basically is flat and level on the wall when it sits. That's kind of it, all in the tricks of everything. Good luck, and you know, we like doing things different because stock is boring. Have a good day.